Oh, yeah.
Now you can.
Great. Thank you. I'm wondering, Guido, if you could run the slides, or do you want me to?
I can go through the slides, but give me 1 second to get them.
Okay. In the meantime, welcome. This is the WEBRTC WG Working Group Meeting. This on October 21st, 2021, 2025. So only members of the W3C WEBRTC Working Group can make substantive contributions. And slides are coming up. All right. So we abide by the IPR policy that you saw. And next slide. We have a new meeting link. It seems like nobody yet used the old link, so that's good. So this is the new meeting link going forward. And we have some future meetings. Next meeting is the TPAC 2025. You'll see a link to the schedule there. We have 3 meetings, Tuesday, November 11th from 4:30 to 6 in Japan. Thursday, November 13th, we have 2 meetings, one at 9 a.m. and a joint meeting with the media working group at 1:45 local time, Japan. And next slide. This is, let's see, code of conduct. Let's act professional and follow W3C Code of Ethics and Professional Conduct. Next slide. We use raise hand tools in Google Meet. Please raise your hand if you want to speak. And we have a queue. Document status. Posting in the W3C repo does not imply adoption. That usually requires a call for adoption on the list. And next slide. And here's the issues for discussion today. So we have, first up is Henrik.
Yes, so I'd like to begin the meeting by talking about remote tracks and muting and unmuting. So what is a muted track? It's a track that is not producing any frames. So I prepared this quiz for you. If my track isn't producing frames, does that mean it's muted? Option A, clearly, you just said so, or option 1. Option 2, not necessarily. Mute implies silence, but silence does not imply mute. I think this captures the confusion that all mute issues over the years have been about. But if you catch this, maybe you're good at lawyering or something. So next slide. What are user agents doing today? Chrome does number 1. It mutes if it detects that frames have not been flowing for a while. And how long is a while? Well, it's based on a frame rate heuristic. So, and it's video only. While I believe other browsers does not do this. And that's why there's so much confusion. So there's some problems with the number 1. First, we don't want to standardize arbitrary frame rate heuristics because heuristics are bad for variable frame rate sources, and we don't know if the app wants to mute or not. And it doesn't, the definition for this frame rate muting doesn't work for audio because there we don't have no frames, we have silent frames. So the spec language today implies quiz answer 2, which is that if frame stops flowing, that does not mean we mute the track. And I believe this has consensus. It appears that this is what people seem to agree on. So I just want to confirm that here. Just a note that if we don't mute when frame stops flowing, that does mean one change in behavior, which is that if you call sender replace track null, then the receiver on the other side will not mute. Right, so potential problem or not. Next slide. If you want to detect the frames are not flowing, you can just poll get stats. So that will be the alternative to listening to mute. But my proposal is that we shouldn't mute here, which means no spec change, and we just need a bug fix in Chrome. But Janivar, you raised your hand.
Yeah, just to confirm that I agree with you that this is what the spec says. I think the media capture main spec defines two control surfaces, if you will. One is track enabled, which is for the website, and the other one is muted, which is for the user agent. And I think that's how it was set up. These two individual switches would be able to turn on and off, and you would only see media if they were both on. And I think no one would suggest that we should, disable the track because frames were not flowing. So the mute signal is an express signal from the user agent that we intended. This is the reason why you're not seeing frames, not the other way around. Cool.
All right, does everyone agree? This makes sense? I just hope we don't break any app when we do this. Okay, good. Looks like we have consensus. So next slide. Right. Sorry, I forgot. There's one more thing here relating to mute and unmute that was brought up in this discussion. And there's if the SSRC goes away due to RTCP timeout, then the spec says to mute. So the problem with this sentence in the spec is nobody has implemented it, does not have any web platform tests. It lacks a clear intent from the remote side that you wanted to mute it. And there's language other places in the spec that says that we should not, the SSRC does not go away just because you make an M section inactive. But if we mute on RTCP timeout, maybe that's a contradiction. Not entirely sure. But I propose that we remove, for all the reasons listed, we remove this sentence to mute on RTCP timeout. We still mute on RTCP by, because that has intent. Does this make sense to everyone? I see thumbs up. Take a note. Thumbs are up. Okay. Consensus? Sounds like it. Next slide.
Just do you have scribe and have we recorded the decision? That's the only thing.
Yes and yes.
Thanks, Tom. Okay, next issue is on SSRC change event. You can go to the first slide. So let's just recap. I presented this like half a year ago before parental leave. So we have talked about this, but I want to recap. So you can obtain the SSRC and CSRC values of the last decoded frame by polling get synchronization and get contributing sources. And apps care about getting these values in timing sensitive scenarios. So common use case is that you update your UX to show the correct video tile with the correct participant name, or when someone is speaking, you indicate who is speaking. Perhaps you show a volume bar. So if you poll too infrequently, there would be delays in the UX. While if you poll thousands of times per second, that would be inefficient, and in either case, it's unergonomic. So in the November working group meeting, I proposed that we add an event. So when the SSRC change, you fire the event. That's basically it. We're not adding new information. We're just making a convenient event that lets the app know that something happened, so that it can have less delays. And we now have a PR. So the quote from was that we have rough consensus with concerns noted on related to on-unmute interrupt, which is a bit vague. So can I merge the PR or not, basically? But if you go to the next slide, we can talk about what this supposed concern was. So the concern was, well, what if you use on SSRC change? If we have that event, that could be a reason not to fix track.unmute, the remote track on unmute. So here's some reason why I think we should not be concerned. Well, number one, or number 0 is we just talked about remote track mute, unmute, and it sounds like we have a agreement about what we should do. Number 1 is Chrome. We've now started working on implementing track.unmute. So this would not be a reason not to fix this. The reason this change was rolled back was actually because of the frame rate problem talked about earlier. But now that that's we agreed to remove that, I think this will be able to get fixed. But in either case, on unmute represents the SSRCs live. So this is actually something that happens at packet reception, which means prior to jitter buffer and prior to decode, while the SSRCs of these getters is the SSRC at the decode time, and this could be hundreds of milliseconds later. So the idea that one API can replace another API when they fire at different points in time seems wrong to me, and we need both of these events. And they both have consensus. So next slide. Can we just merge my PR, please? Anywhere?
So I had some questions. You mentioned that SSRC change and CSSRC change are based on decode. Could you elaborate that? I thought that was RTP. Those were RTP concepts.
When you call get contributing sources or get synchronization sources, the SSRC and CSSRC values that you obtain are the last decoded ones. And you can see one of the use cases of get synchronization sources is to get the volume, because you're updating this yiggly icon that we have to show the volume. So you would not want that needs to be as close to play out as possible. So if you have a jitter buffer that's 200 milliseconds long and you show it at the reception time, that wouldn't work. Also, I think some of this information you can obtain via, like when you decode, you actually measure the volume. I don't remember, but the point being that this is existing APIs, that they are at different points in time, and it's observable that they are different.
Okay, that makes sense to me. So you're basically saying these events are additions to the existing APIs that are decode specific for getting these. You could poll right now, right, and create these events.
Yeah, you can shim and get this API, but you would either get delays or possibly performance issues.
So my feedback then is that maybe can we update the PR language to make that explicit? Because right now I'm reading on the slide here that it says to be updated based on the contents of an RTP packet. And that seems to be different than what you said.
We can clarify that. I found that confusing in the main spec as well, but it does say decoded.
Okay, thanks for clarifying. I'm happy with that in that case. I'm also very happy to hear Chrome fixing that bug. I'm wondering, do you know the timeline? I think the concern that I had originally was that I think the person filing the issue mentioned that there was a pattern of looking for SSRC change. Their use case was basically to find if the media was flowing. So I'm just wondering, it would be nice timeline-wise, do you think the unmute will land first?
I don't know because it's Philip Henke who has been fixing on unmute. We had to, so it got quite far. I forget if it was beta or stable, but we almost shipped this, and then there was this edge case bug where the fact that one part of the code said mute unmute based on packets, and another part of the code said mute unmute based on frame rate. These two would contradict each other, and you could get stuck in a mute state even though you shouldn't be muted. This caused us to roll it back. And I hope we can roll it back again as soon as possible, but because this is actually people contributing, I don't want to announce a timeline.
No, that makes sense. But to clarify, Chrome's intent is to fix this.
That's our intent. Yes.
No, that's good to hear. Thank you. And I don't have a problem with going forward with this PR.
Cool. Thank you. That's all for me.
So consensus
With the clarification that it's decode.
Okay, Yuan, it's your turn for.
Next slide. So we'll talk about 5G network slicing. Maybe some of you don't know about it. I didn't actually know about it since a few months. So with 5G, you can have one device and it might be able to use 5G in different ways simultaneously. So one application can have a connection that will use 5G in one way, and in parallel, it will have another connection that will use 5G in another way. And this allows basically to use connections that are tailored for the application needs. So if one application needs to have the best latency possible for a given connection, like a video call application, then it will be able to get it. And if in parallel it's doing some other kind of networking, like regular images downloads or whatever, it will use the regular 5G setup. So 5G network slicing is now available in 5G devices like iOS and Android, like typical phones. It's being used by some native applications, video calls or cloud gaming. And there's some support. So for these native applications to enable 5G network slicing, they need to use some API. And for iOS, for instance, the application needs to say, hey, I'm a gaming application, for instance, cloud gaming application. And then once it has done that, for a given connection, it will say, this connection, I really want to get low latencies for video streaming, and I really want it to have like best bandwidth, best latency. So that's how it's working. Next slide. So the question is, can we use 5G network slicing for web browsers? What can see is that a web browser is doing different kind of networkings for different purposes. So for instance, you load a web page, you fetching JavaScript or MSC video chance, whatever. This is typical HTTP requests and responses. But at the same time, the web browser may use networking through peer connection to do video calls or cloud gaming. And in that case, it would be great to use low latency 5G networking if it's feasible. So overall, the user agent can do as optimizations for web applications. So the first question is, should web applications be able to influence user agent decisions? That's the first point. And the second question is, as we see, if you're doing HTTP, then maybe you do not need super low latency. But if you're doing WEBRTC call, you might want low latency. But WEBRTC or web transport, for instance, may be used for various purposes. And so in those cases, for those APIs, how do we know when to use 5G network slicing? Yeah, Peter?
Thanks.
You're muted.
Is there any risk to the user agent enabling this and then something going wrong with applications, and then they're like, "Hey, I didn't want this turned on."
I mean, it's always a trade-off. For instance, if you're using 5G network slicing for low latency, in principle, maybe you could have bandwidth to be reduced a little bit. In practice, it's not the case apparently. But there are some potential 5G network slicing that could be used with a sensor for long-lived connections and high latency. And in each case, you preserve a lot of energy. So in principle, you could have some downside if the user agent is doing it wrong. In practice, I don't think there will be, for typical WebRTC calls, for instance, I do not anticipate any downside. But it's really the user agent that can decide, I think, what's and when to enable 5G. Whether the web application can help the user agent, that's the question here.
Well, I can imagine the web application being able to have something to say, I opt in or I opt out. But I guess the big question is what the default should be if they don't do anything.
Yep. And I guess that's after my answer would be that for peer connection, the vast majority want low latency. And that's why user agents might prefer to do opt-in by default, and then maybe web application might want to opt out if they really think it's interesting. But yeah, we'll discuss this later, I guess. Tim is on the queue.
Yeah, I mean, I'm happy to wait until you've finished, but just wanted to say that, like, basically this doesn't tie in with our experience of how it how carriers are delivering it to kind of normal mortals. I don't know, maybe you've got a slightly different perspective from within Apple, but for us, it's an API call to a server to request a network slice rather than being able to do it on device. Like you have to, and it costs money. So like this isn't, and the other thing I vaguely feel is that I don't think it's a baked thing, because one of the things that we wanted was to shift the priority between uplink and downlink. And in theory, that's available, but none of your categories covered that. So I think it's still a, like I'm in favor of something here, but I'm not sure that we're going to come to a good conclusion yet.
So what I know most is how the level of support in iOS. 5G network slicing is a term and can be used for many different things. And what I'm talking here is basically what iOS and probably also Android is supporting, which is much more restricted. Yanivar?
Yeah, so this is fairly new to me. So, but I think my reaction would be I don't think I would be opposed to, I don't know if you're thinking more declarative APIs. I don't think we should.
It's the next slide.
Yes, I think, whatever we can do, I think the user agent should stay in control basically, and whatever we can do to declaratively describe websites, applications, like for low latency needs. Basically, if we can have APIs that describe the application needs to the user agent and let the user agent, then the user agent can have better information about where to delegate these extra resources. So I think
I tend to agree with
you're thinking of. Okay.
And the second thing is, I'm not sure talking about 5G specifically is the right level. So maybe it's more like this application wants best low latency possible, for instance. In that case, the user agent might say, okay, I will use that specific 5G network slicing, or maybe some terms like that. So in the next slide or so, there's the congestion control attribute in web transport, for instance, which is a way for the web application to say, hey, I'm using web transport, and I like to go there to that kind of efficiency. And user agent, please do your best to to support that kind of efficiency. And that might be a possibility. But let's go through the slides then, and then we can talk.
Great.
I see Harald on the queue, so maybe Harald, and then I'll continue.
Yeah, so you're making a point. So if you want the application to make decisions that are at all relevant to 5G network slicing, I mean, I first heard about 5G network slicing as the greatest thing since sliced spread about 10 years ago. So it's about time that we actually start looking at it. It's not been needed for 10 years, so I suppose we can wait until 6G. Anyway, so either we have to have an API that lets the application learn about what slices are available and make it and what their properties are. And as Tim noted, that might be actually dependent on what the device asked for and what the device is willing to pay. And or we have to say that no, we should just let the application say, hey, this is the kind of thing I want to achieve, and let the user agent set about achieving it. Now, we have had a number of discussions a number of times about whether the application or the user agent should be in control. And usually, big applications tend to say that they need to be in control because they have, and because they are actually capable of changing their minds, and they just want the platform to be predictable and do what it's supposed to do. And of course, the other side is that the browsers tend to say that, well, all the intelligence should be in the browser, so that the application should just get what it's coming to them. I have seen both arguments argued with force, and it's no different in this time. But I'm not in a hurry. We've lived without it for the first 5 or 10 years of 5G rollout, and we can probably discuss this for a year or two more.
Yeah, definitely. We can also see things being deployed, and then we can learn for it. I tend to agree with the approach that user agent at the end of the day is in control, but web application can help user agent make the best choice. So the next slide here is oh no, come back to. Yeah, so there are use cases for letting web applications influence user agent choices. I would think that WebRTC applications in their vast majority might prefer low latency. But it's true that some WebRTC applications do not require low latency. It might be best for the users to not require a 5G network setup that is triggering low latency. I'm thinking about peer-to-peer CDNs, for instance, where if you're doing like an optimization for HTTP caching through peer-to-peer CDNs, then low latency is not needed. There's also 5G network slicing is apparently potentially being used for communications with sensors, like probably long-living and high latency. And in that case, maybe WebRTC could be used. I'm not quite sure, but with sensors, and there you would not require low latency. If we look at web transport, I think that currently web transport applications do not really require low latency if we think low latency in terms of WebRTC. But in the future, as we are seeing with the congestion control low latency value, they may want low latency in the future. So that means that for web transport as well, the usage of the API itself might not be sufficient to always select the best 5G network slicing setup. And the third use case that I heard of was A/B testing. So if some web applications may want to enable, disable, and then decide. That's not my preferred scenario, but it's still a scenario. So, so let's now go to the last slide, which is discussing a few different options. So we could have the user agent decide letting the user agent in full control and expose nothing. Maybe we could add a note to implementers in WEBRTC PC. That might be something to consider if some user agent implementers start to play with 5G network slicing. It could be just an advice, and we can stay like this. And then in a few years from now, if we learn new things, then we consider adding an API. We could add a dedicated 5G network slicing hint API, so per peer connection or per web transport. As Harald mentioned, that kind of API might require to expose capabilities and so on, which might be which might lead to potential issues with fingerprinting and so on. So that's a possibility, but it might be hard. And in the middle, there might be like a more general hint API saying, hey, I want to use peer connection for and expect this kind of efficiency. So I expect I prefer low latency, for instance, or I prefer bandwidth, or I prefer efficiency, like battery life. It's sort of similar to web transport congestion control, meaning that if web transport, for instance, if a web page is using web transport and saying, hey, I really want low latency for that web transport connection, I would expect user agents to update their congestion control to favor low latency, and they might also want to use the same information for selecting the best 5G setup. So one possibility is to use a new WEBRTC configuration member telling about what the web application is expecting. And then by default, I would think that we would use something like low latency, something like that. So thoughts? Yep, Henrik.
If you change which 5G network slice you use, does that change which ICE candidates you need to use? Or
so I don't think so. No.
Okay, so it like entirely happens behind the scenes.
Yep. Typically for iOS, it's at the time you instantiate the connection, so the UDP socket, that you will need to tell whether this particular connection should be using a specific 5G network slicing or not. Is this connection typically the question is this connection be used for low latency video, for instance? And it will remain like this for the lifetime of the connection.
Okay, but so in theory, if I change from low latency to bandwidth, the fact that I need to recreate the socket to get that probably means that the connection needs to die. So I need to do an ICE restart.
So you could do that. My inclination would be that the WEBRTC configuration member would cannot be changed. It's immutable. So it's at the time you construct your peer connection that you say, okay, I want this.
Okay.
But we could go this way, but I'm not sure it's worth the complexity. So initially, I would start with very simple, very constrained. If we want to expose an API,
makes sense.
Jonivar?
Yeah, so just to clarify on your slide there about web transport, I think, web transport, an important customer for web transport is mock media over quick, which is to be called, which is now more a general system. So I think, I don't know if it's accurate to say that most web transport applications are not low latency. I think we want low latency, but we want better low latency than we have.
But there's no congestion control
right.
tailored for low latency. So that's why I was just mentioning that. Yeah.
Yes. No. So I think I would be favor of, as long as we're talking about a hint, I think I would be opposed to any way for the website to learn whether it has network slicing or not. I think Peter had a great comment in chat here that we don't want to create a situation where you're relying on payment, for example.
Agreed.
Yeah. Okay. Great. Thanks.
So you're fine with 1 of 3, I guess. A hint is okay.
But I think if we can piggyback on another surface like Web Transport's congestion control, or if there's a RTC configuration member that you can't use get configuration to learn what you got or not, that might be okay.
Yeah, the principle for the configuration member is that you set it when you create the peer connection.
Yeah.
And then you go with it. You don't learn anything.
And it would be something like low latency, please.
Yeah.
Yeah.
Or maybe by default it would be low latency, and then maybe we could opt out, because
Okay.
I think that in general, given the usage of peer connection, the default you might want to use low latency if it's available.
Yeah, I worry about if this is a scarce resource, we probably should have it be opt-in, because people always want more, so not less.
Maybe, yeah, we can talk about that. I guess, yeah, I think that, for instance, I know that NVIDIA is interested in that, so they will certainly turn this on. But it might be a bit sad for over WEBRTC users to not get to it until they learn about it. So,
well, for maximum UA information, it might be an enum then with 3 values where there's a default.
Yeah.
And 2 values that say explicitly, I care about latency or I don't care about latency.
Yeah, that seems reasonable. Something like that, yeah.
Great, thanks.
Tim?
Yeah, I mean, just this information is probably a year or so old, but last time we played with this, the results of changing slicing, basically you got a whole new IP address. Right, so I'm not sure that's still true. I think they fixed that, but it's quite a big kind of under the hood. It's quite a big change. So yeah, I think like doing it dynamically is going to be risky. So I like the third option of like making it a configuration member.
Beautiful.
What I'm more worried about is making that an enum or something, because I think like one of the things I would want to be able to do would be say that I'm interested in uplink, that uplink is what I really care about, or downlink is what I really care about. And that's one of the things you can do with slicing. But and the latency for uplink and downlink aren't necessarily correlated. So you can do, I mean, whether the network lets you do this stuff is a whole other question, but at least in theory on a private network, you can make your uplink much lower latency than your downlink, for example. You just allocate different sets of slots. So I would be very careful about having a very constrained set of enums here. And if it is constrained, I'd like uplink and downlink to be part of the hint process. But like I say, this information may be well out of date. Things may have changed in the last year.
Okay. I think it's worth digging into that. I guess an enum you can add more values progressively as well. So we can start with a few values and then increase it. I didn't think about the uplink downlink, but yeah, if you can provide more information there, that could be useful. Peter?
So I think that at a high level, it makes sense to have an application be able to say, I don't really care that much about latency. But in practice, I kind of worry that for almost everything that wouldn't do anything. Like, I don't think anybody's going to go change the RTP stack to be more or less latency sensitive, for example. And if we have a third enum that's like, I really, really care about latency, where the default is I care about latency, and the only thing that does is trigger this extra little thing, it seems a little awkward, like to go say, yes, I really, really care about latency when it's clear that if you're using peer connection in the first place, unless you say I don't care about latency, the default is to care about latency. So
Yeah,
on one hand, it kind of makes
Mm.
sense, but on the other hand, when you get into the practical details, I'm not sure.
I think Yanivar's proposal about default was that the default is the user agent can do whatever it wants, basically. And then low latency, yeah, you will try to use the 5G network slicing. And if you do not set low latency or default, then you're sure that 5G network slicing will not be used, basically. At least in the current state of OSs like iOS.
Yeah, I guess I just feel it's a little awkward that if you go to use peer connection and then you have to also say, and I care about latency, but then when you read the details of the documentation, it says, and the only thing this does is turn on this other extra piece of, unless at some future time, maybe something else will change, but you don't know what.
Maybe at some point in the future, there will be different congestion controls in peer connection. I'm not quite sure about this, but you never know. So maybe this hint could be also used to tune some parameters in the WebRTC stack as well. But who knows? Yeah. Sun?
First of all, thank you for presenting this. Like you mentioned, NVIDIA, we are preparing this 5G slicing for better latency for the gaming. And as a reference, we are now working on releasing this support on native implementation, including the Android mobile. So our next goal is to expand this service through the web client. So that's our hope, and we look forward to have this feature be supported by the browser. Thanks, Yuan.
Thank you. Harald?
Yeah, so since Tim mentioned that these properties are probably independent on sending and receiver side, should they be properties of senders and receivers rather than transports?
At least on iOS, it's per socket per connection. So if you start mixing, it's not per packet, basically.
No, I was thinking that if we go with an API that the application tells the UA what it cares about, it could say that I care about having my packets go out as fast as possible by setting low delay on the sender, but I don't care how fast packets get to me by sending high delay on the receiver.
Okay, so instead of one configuration, maybe two, one for downlink and one for uplink.
Yeah, and conceptually have the senders and receivers in initial keep the information.
Okay.
Here's a thought.
Yeah. So what I'm hearing is that there's interest in a general hint API. There's sort of three possible value, default, low latency, and no low latency. There's a separation between uplink and downlink. And I think what we can do is try to prepare a PR and prepare a proposal and maybe come back to the working group with a concrete proposal around those lines. And it will be probably in WebRTC extensions then. Okay, sounds good. Thanks.
Well,
okay, so different subject, S-time processing model. So we talked about this quite a few months ago, and since then there has been some progress. So a new S-frame RTP format draft has been published. It will be discussed at next IETF meeting. But basically, so the current draft allows to support both per packet and per frame encryption, and it will be really up to the application to decide which flavor to use. There's an example there. You can see an SDP sample with an audio and section, and if you're interested in S-frame, basically you will add the A= S-frame line, and that will mean that all media will be sent using S-frame. So it's not one codec amongst others which will be S-frame, but it's any Opus or whatever codec that will be S-frame before being sent. And on the same, conversely, on receiver side, you will need to do S-frame before actually decoding data. So the proposed negotiation rules are that S-frame negotiation happens at the M section level. As to simplify things, the approach would be that S-frame negotiation is sticky, meaning that an M section can start with no S-frame, so just as today, and it can go to start using S-frame. But if you start using S-frame, then you will need to continue using S-frame for the lifetime of this M section. If in the case where one of the peer does not support S-frame, so let's say you're sending a description with S-frame and then you receive a description without the A= S-frame line, then it means that the other peer does not support S-frame. So the plan is to reject this particular M section, but not other M sections. As you can see, the current proposal is fairly limited in STP negotiation. It's just to say, hey, I'm planning to use S-frame. Concerning the other parameters that are needed to actually do S-frame processing, like crypto suite, whether to use per packet, per frame, or keys and so on. This is not done through SDP, so it will be done out of band. Typically, the A= S-frame line is telling SFUs that they should not look at the content because the content is encrypted. But the crypto suite, the per packet, per frame, the keys, and so on, this is more interesting to the nodes that are connecting to the SFU. So that's where the current draft is. Next slide. So the question here is how we do, what's the processing model and how using this S-frame RTP format is happening with WEBRTC encoded transform. So the proposal here is that if, so we have this transform attribute and you can set a transform, it can be either an S-frame transform or a script transform. So if you're using an S-frame transform, that means that for this M section, you're planning to use S-frame. So you can see transceiver.sender.transform equal new S-frame transform. Then bang, it means that the A= S-frame line will be added to this M section. For script transform, the idea is that we would add a new parameter called type, and then type S-frame. Then bang again, it means that you actually want to use the S-frame packetization format. On receiver side, it's the same. Basically, if you have an event, you have a new transceiver, a new receiver here that you learn about. You set the transform, and let's say that the M section didn't have the A= S-frame line. Then there will be on negotiation needed the negotiation needed event so that you can actually renegotiate with S-frame enabled. So what's new here is, yep, Yanivar?
Just a quick question. How do you get S-frame options to the script transform?
So I would say at this point it's a little bit by shading. I know that you would prefer that there would be a new type S-frame in the options object that is being transferred. So either we do that, which means that existing application that use type will have to deal with it to use S-frame, or we add a fourth argument.
Okay, yeah, I remember that discussion. Yeah,
Yeah.
That makes sense why you left that out.
Yeah,
No
so
question at this
currently
point.
it's you probably like this this API shape, but yeah.
I think you're presenting the right abstraction, so thank you.
Yeah, Henrik.
You said if the A equals S-frame line was not present, but you wanted to use S-frame, you would renegotiate on the receiver side. But if it is present, do you still need to create the S-frame transform, or is that created for you?
So you will need to create the S-frame transform or the script transform to actually being able to decrypt. So negotiation will be fine, but if you do not set the transform, RTP packets will be dropped because you will not be able to decrypt.
Okay, so then my only well, there's two questions. So one is, okay, you do set up the S-frame and then everything works, but I think until you set it up, since you negotiate at one point in time and then shortly after you create the S-frame transform, I think there's a race condition where like the first few frames you might drop them because you don't know how to S-frame transform them yet. Is that correct?
So yes, if you set up the S-frame transform, it will not accept non-S-frame packets, and if you're not setting the S-frame transform, the S-frame packet that you receive, they will not be decrypted, so they will be dropped as well. Yeah.
What I mean is, like, even if you do this ASAP, just because it's a race condition, you could drop frames. I don't know if this is solved by doing some additional buffering at the start, or
on the sender. If let's say you start with no S-frame, and you set the transform, so you need to renegotiate, and until the negotiation goes back to stable, that you send your offer, you get back the answer, you apply all descriptions. Until then, I don't think that the S-frame packets will be able to flow, so you will not be able to send them. So there will be some delay in the switch. So the switch is not super great.
I mean, if I ask you to send me stuff, the fact that I asked you means my S-frame is already set up. But if you ask me, please receive this, I'm gonna send it to you. If I need to hook up to the on-track event on my side, like even if I always agree to doing S-frame, if I need to do something inside the on-track event, oh right, you mean by the time I do the answer, I've already set it up. So you would listen to on-track, set up S-frame, and then create the answer. Is that correct?
Yeah.
Is that okay? Then we don't have a race. That's good. But I have one more question or thing to point out. You said that if the A equal S-frame, if you don't want to do S-frame, you would reject the M section. Like that would be the rule. Well, I believe that by default, a backwards compat thing. Like
it's not exactly that. It's not exactly that. Let's say that A supports S-frame and B does not support S-frame. That's where A will send an S-frame offer. B will not understand that. So B will return an answer without the S-frame line. And then A will say, oh, okay, this guy does not know about S-frame. So I'm
Okay, so
rejecting this section.
it's A that's rejected. Okay, that makes
Yeah.
sense too.
Yanivar?
Yes, how would the application, how would A know that without reading the SDP?
Well, the
Do we
user
need an
agent,
API?
when you're setting the remote description, my guess is that we will add some checks that, oh yeah, there's no S-frame line. And I know I implemented S-frame, so this end section will be rejected by the user agent, not the web application.
It'll be rejected, or do we need to expose some API that says whether S-frame was successfully negotiated? Would you want to fall back to no S-frame, or do you want your... because failing the
so-
SDP negotiation seems a bit rough, that's all.
So I was thinking that no, like rejecting, and then if we allow the web application to know why the user agent rejected the end section, that's fine too. But it's not. Yeah,
Maybe
It's
I would-
already
it
will be
possible to reject M sections today with or
Yeah.
without S-frames, and we don't have a rejected M section event.
Yep.
Okay, fair enough. Thanks. I guess we could also
Brian?
throw
Oh,
on
sorry.
setting the sorry, I mean we could also throw on setting the preset and S-frame transform on a receiver. Oh, that's too early. Okay. I'll have to think about it.
Okay, Brian?
Yeah, this was the one I was worried about. There's a bit of ambiguity there, where if a far side doesn't understand an attribute, it thinks it can just ignore it, but it doesn't know the semantic necessarily of the killed M line. So I guess the offerer will have to take action to kind of shut things down and redo stuff here is the idea.
Yep, the user agent will implement that logic, and the web application will have to somehow react to that, meaning maybe creating a new end section without S-frame, for instance, or doing some other stuff.
But I think part of this trade-off, or part of the reason you went from we were talking about to do this, was to address the other thing Henrik had brought up, which is that if you can kind of lock the association to S-frame on the M lines, this is how you kind of avoid the race condition type stuff, because it is fixed. And the trade-off there, I guess, is that you can run into this kind of awkward situation if the far side doesn't do it. But if the S-frame association isn't dynamic, then we don't have the race, at least.
Yeah, we try to do the simplest and less flexible approach. Hopefully, still allowing web applications enough leeway to implement what they want. But the more fixed, the more rigid it is, the less likely there could be an issue with, for instance, web applications thinking that S-frame is used and S-frame is actually not used, or something like that. This is something we want to avoid.
The thing that
Well,
the other scenario there I was worried about that maybe we just need to kind of clarify or document is if you're talking to someone and you want to be able to support either way, S-frame or not, right? And so you give it one S-frame M line and one non-S-frame M line.
Yeah.
But the far side doesn't know S-frame, so it answers back on the first one and says, well, I don't know what S-frame is, but I'll do media on this one, and then rejects the other one because it doesn't want to do two things. And so then A is saying, oh, well, it rejected my S-frame M line and thinking we could just do regular media on it. But I know actually I can't do that. So then we got to do, I don't know, at that point, it's got to do a whole new offer answer or something, or what?
Yeah, maybe. Or the first end section is the one without S-frame. And
if they assume that the far side
like
will take the first one, I guess, or some convention like that. But if it's an unknown endpoint, maybe that might get a little tricky. But
sure,
I don't know. Maybe that's just something you think we would call out on what the recommended way to handle it would be.
Yep. Henrik?
So if I understand it correctly, if A offers S-frame, B doesn't know what it is, then B will just remove A equals S-frame, because that's what we do by default when we don't know what we're doing. So it will answer. It will accept the offer, but it will just remove S-frame. So when it comes back to A will notice, oh, S-frame was removed, so I'm going to reject this, and that's fine. But at this point in time, the transceiver will only be stopped at side A. It will not be stopped at side B, which is it's interesting to note. It doesn't cause any issues, but it's an interesting to note. So the next time A creates an offer, that's when it will be signaled the fact that this M section is actually stopped. Until then, the B side B will just have a receiver, and it's waiting to receive something. It just never receives it, which again seems fine. If offer A wants to do fallback logic for backwards compat reasons and use a different M section without S-frame, it's free to do so. I mean, I'm wondering if it could be detected in the API, or if you would have to like manually parse STP. I guess you noticed that the M section was rejected. If the transceiver changes state to stopped, you'll know that you should try again. So I guess you don't need any APIs.
Yeah, if we see that web applications, they have to learn through parsing that the M section was rejected due to S-frame missing, and it's a pattern that starts to grow, I think we should expose some information about it. But
you could probably just like look at the transceiver and see if it changed direction to stopped, because then you'd know it was reacted. You wouldn't know why it was reacted without parsing STP. It's probably
you don't know
good
why.
enough. It's probably a good enough hint.
Approximation? Maybe, yeah. I don't know. But now we are seeing that there may be several reasons why transceiver is stopped. And yeah, if web applications, they start parsing SDP to know exactly why, then yeah, we could expose the information of why it has been rejected. But so far we lived without it, so I'm hoping we can continue. Casper?
Hey, I have a question on a little bit different topic. On this picture, you don't show how actually S-frame mode should be negotiated. So if it should be on the S-frame options, or in the way how it was discussed like a couple of months ago with the up transceiver init options.
The S-frame mode meaning per packet or per frame?
Yes, per packet or per frame.
Yes, so S-frame transfer object would have this option in the S-frame options that is given. So you create the S-frame transform object, and when you create it, you pass the mode. For script transform, currently it would start with per frame only, and we can envision supporting per packet. It's the last slide, I think, of this presentation. There are ways to make it work with script transform as well, but so far we haven't received requests for supporting per packet processing via script transform. So I would leave it to another day until we get some requests. Harald?
Yeah, just mentioning that the absolute rule in SDP is that you ignore everything you don't understand. So if you want to offer either to communicate in the clear or communicate using S-frame, you have to be able to send the offer with S-frame, get the answer back where S-frame is deleted because the respondent doesn't understand it, and then turn off S-frame encryption for that transceiver. So either by not creating the transform, or by changing the transform, or by instructing the transform not to encrypt. So that's just how you have to do it.
So the principle in that case where you discover that S-frame is not supported by the other party would be to create a new transceiver.
Either that, or you manage to get the transceiver that you have to not encrypt. if you want to send not encrypted, of course. I mean, most cases where you want to send encrypted, then you want to at least go back to the user and ask, hey, this is going to be non-encrypted. Are you okay with that? Or something like that. So you'll probably create a new pair connection instead.
Yeah, we might. Yeah, that's another option. Like a new transceiver can be on a different connection. But yeah, I'm hoping we can avoid the idea that you start negotiating S-frame, you discover that S-frame is non-negotiating, and then you have to switch transform. The only case that I thought about was when you roll back. So you created a peer connection, you did no S-frame, and then you want to migrate to S-frame, and you discover that it's not feasible. Then in that case of rollback, I think that setting back transform to null is the way to go. That's in one slide. So that's one thing that I think we will need to dig into when writing the PR, because we need to get it right. Hopefully it can work. I'm hoping Henrik and you can help as well.
Yep.
Jonivar?
Yeah, sorry, I keep tripping over this. Looking at this slide, it was my impression that, we can, just like we can say new S-frame transform to turn on either S-frame or S-packet. I don't see why we would need to limit or not support S-packet just for having a script transform. And so my question there would be, in your mind, on the receiver, if we look at the receiver, if I said a receiver transform to a script transform with type S-frame, would that receiver would S-frame decryption already have been done before the JavaScript gets the data or not?
So on the receiver side, you receive you receive an S-frame chunk, and the S-frame chunk can be several FTP packets payload that you concatenate, or it will be just the payload of a single packet. And this is the S-frame RTP format that tells you, because there will be a start and an end bit there to tell the S-frame packet depacketizer whether to concatenate or not. So on the receiver side, let's say that you have somebody that is sending you per packet S-frame. Then on the receiver side, you could, in theory, what would happen is that you would receive in the script transform a new encoded video frame with encrypted content. And the script transform in that case will need to decrypt it, and then it will be a chunk that it will process by feeding it to its GS depacketizer, to its GS codec-specific depacketizer. So let's say it's H.264, then you decrypt, you have an H.264 payload that you feed to the depacketizer, and you need to wait the next one until the depacketizer tells you, hey, I have an H.264 frame. And in that case, you take it and you have to pass it to the writable stream. That's how things would be done. On the sender side, yeah, I'm not sure I'm clear.
I have a different view though of what we could use here, because I don't understand why the JavaScript needs to even see the encryption. Just like if I specify type S-frame, why can't the user agent decrypt the S-frame for me, whether it's done at the depacketizing step, before or after the depacketizer? By the time JavaScript comes in, most of the use cases seems like they could deal with the unencrypted version.
So if we do that, then we need to expose some key management to script transform. So basically, script transform would be an S-frame transform plus another JavaScript.
Yes.
I'm not sure. I don't know. I was thinking that some script transform they might be used for doing S-frame, and maybe they will have their own crypto suite, for instance, that the user agent is not supporting. And in that case, how do you do?
Well, I think there are trade-offs here. I mean, there might be, even if there might be some use cases for that, it would seem a shame to leave out S-packet support entirely. So,
it's perfectly feasible to add S-packet support in Script Transform. The thing is, it probably on receiver side, I don't think it requires new API. On sender side, it requires new API, because on sender side you have an encoded video frame, and if you want to do per packet, and the Script Transform might want to have its own way of splitting per packet and then applying S-frame, then you need to give to the S-frame packetizer where to split chunks. And there are various ways to do that, either enqueuing several frames or providing delimiters to the depacketizer, to the packetizer. So it's feasible. It just that it will require some changes either to the API or to the processing model. So it's work we could do, but so far nobody requested it. So that's why I'm fine doing it after we do the other stuff, because it seems lower priority.
It might be, but there's a question here. Looking at the slides, it's not clear. I think we have to describe better how we imagine this to behave. So, like for the receiver, for example, it sounds like you're saying that the JavaScript in the receiver transform would then need to specifically pipe if it's going to receive encrypted chunks, it would have to then pipe to the now called S-frame decryptor as part of its step. And
for instance, yeah.
Yes. So, and that's not clear right now, I think, from slides. That was because I think, at least when I looked at this, it's also easy to imagine that the simplest form would be, since the new S-frame transform object basically applies magic on sender and receiver side, for that the type S-frame might equally be interpreted as magic, basically, so that both sender and receiver script transforms can operate in the unencrypted space.
We could change type to packetization format.
Right. So yeah, I would like to, maybe after the meeting, we can dive into the different approaches that we could potentially do here.
Yeah. There's a PR. I plan to update it, and we can, as part of the editors meeting, like dig into that. Yes.
Great.
Henrik?
Just going back to the previous discussion about you offer S-frame and the answer doesn't understand it. So currently the proposal is that you stop the M section. And I think that makes, like, as a default option, that makes perfect sense. If you ask to do S-frame, then unless you explicitly say that you're okay with the fallback, then like it's better that you don't, that doesn't work at all, than that you accidentally use unencrypted without realizing it. However, it's an interesting point though, that the fact that the answerer thinks that the M section still exists by default, it does leave us with the option, like, well, should we stop the M section and create a new one that requires another offer answer, or should we just have a way to say, I'm okay with not using S-frame as a fallback? Because if that's the case, you don't actually need to renegotiate. You just don't kill the M section, and media can flow. So it's something to think about, but I don't know how important that is.
Yeah, I was thinking for simplicity purposes, rejecting was easier, because if you start allowing to not reject, then you need an API shape as well, an additional API shape, some options somewhere, which might be fine. But yeah, I'm open to that. But I guess it could be added later on as a follow-up.
Yeah, it might just be a Boolean, but I think it makes sense to not have it as a starting point, since you can just do it like this.
Okay. Next slide. Yep. So some rules, we talked about them, some of them. So if S-frame is negotiating for an M section, and then you get RTP packets, and there's no S-frame, so there's no transform, or there's a transform, but it's not an S-frame transform, then packets are dropped, basically. Conversely, if S-frame is not negotiating for an M section, and you set the S-frame transform anyway, RTP packets are dropped as well. So, for instance, if you start with no S-frame, you set the transform can start to get video frames, and we will start doing its processing. So it will be S-frame packets, but we're still not sure whether the other party knows how to process it. So the idea there would be to drop things, like similarly to I think, like if you want to support to add a new video codec, you need to wait. So I don't know exactly the rules. Maybe I should look at them. But if you want to negotiate a new video codec in an existing M section, and you set it as a preferred codec, I don't know what happens, but I was hoping that you would need to wait for the answer to be applied to actually start using that video codec. But maybe I'm wrong there. So yeah, if we follow that principle, if you migrate from no S-frame to S-frame, it would mean that you will need to do the full negotiation to actually start sending media. Receiver will, on the other hand, be able to start processing as soon as it applied its remote description. Yes, Harold?
Do we have a use case for migration from no S-frame to S-frame? I mean, the simple use case is where you know that you want an S-frame, so you just start off by making one. And if we don't have to support migration, then we don't have to support rollback either.
So that would mean that depending on the timing of when you set the transform, then you update SDP or not. Maybe we could do that.
I just say that you can't set the transform after it's negotiated, which would make life much simpler in many cases.
Yeah, that's a possibility as well. Yes. So maybe it's good enough.
I agree with Harald. So I think by the time you create the offer or the answer, you will like on the offer side, you need. My understanding is setting the transform. That's how WebRTC knows whether or not to put A equals S-frame in the offer. And setting the transform on the on the answer side, let's say offer to do S-frame, and the answer wants to receive S-frame. The only way to avoid the race condition is to set the S-frame prior to sending the answer back to the other side. So I think it should be a prerequisite. The S-frame transform is set when you do the offer and you do the answer. And if that is a requirement, then the question is, well, do we want to support the use case of you negotiate to do not S-frame and then later you negotiate to do S-frame or vice versa? And to that, I would again agree with Harald that we shouldn't support this unless we have to, because not only do you have the rollback issue, but like even without rollback, you have race conditions. If I'm sending packets to you and then suddenly I start sending S-frame packets, or vice versa, you would have an active receiver on your side, and the signaling to enable or disable S-frame would not be synchronized with the media flow on the wire. So you have even without rollback, you have a race condition where should you use the transform or not? You don't know.
Yeah, I think I like it. It will be simpler, and so the idea would be to reject. So the setter would throw basically. If
I
you
think
trying to
if
set
you
the
change the
transform,
transform, yeah, exactly, you should just throw.
yeah, that's simple. That's simpler.
And I
Yeah.
thought this was always the plan. I thought the idea was you always are locked in on the M line, and if you want to be able to support dynamic, you either have to get into a renegotiation thing, or you have to do a double M line situation. You do one set of M lines with and one set without. If you want a more fluid transition between the two, out of band signaling that helps receivers know about which things you want to turn on and off.
So to me, it was always from no S frame from S frame to no S frame was a no. But from no S frame to S frame, that was a possibility.
Oh, we're definitely interested in both of those scenarios, and that's why I asked about I thought the double M line thing from the beginning, which is hey, I'm willing to do S frame or willing to do not, and we kind of have our own signaling, I guess, to be able to manage. Okay, well, which ones are we kind of currently sending and receiving on? But that might change, but to avoid another answer, but fine with the fixed M lines if that's what we're going through. If it it avoids some other radiation.
Yeah, I think we need to discuss it a little bit more on GitHub. But yeah, either we use. So I was thinking that no S frame, 2S frame could be a use case for you, but the reverse was not really a use case.
No, we definitely are interested in both directions. The possibilities.
Okay.
I think the only way to avoid the race condition between packets and turning this on and off is to synchronize the two.
So the thing is that if you start applying S frame, you're using new payload types, and that's a way to disambiguate as well.
Okay.
Yeah. So, and for instance, if you have two M lines, one with a S frame and one without, if they're part of the same bundle, it was advised that they should have different payload types for the same H.264 or VP8.
Oh,
so
wouldn't mid be sufficient to help disambiguate which M line, and then even if you had
No, so it was feedback from Jonathan that said that for a given bundle, it's way better to have this payload type, it's using S frame. This payload type, it's not using S frame, and that apparently was solving a lot of potential issues. I can talk again with him about that, but I thought it was a good principle. So the issue, one of your issue there, Brian, is if you have two M lines, then you have twice. You have more payload types. So I guess you will need to select video codecs and restrict them to have a minimum number of payload types.
Yeah, I think it'd be great if we didn't have to do that. But if that's where we're locked into to make other stuff work cleanly, then that's where we're at probably.
Even if you can tell the difference with using the payload type, wouldn't it be a contradiction if you set your S frame transform and it's not used yet because you're receiving packets from before you had set it, or vice versa? In my mind, the only way to avoid the race condition is to sort of start from scratch, which the natural way to do that would be to just replace the M section with which the app can trivially do by just renegotiating. Just needs to add a transceiver.
I'm buying the argument that we can start with double M sections, and it's simple. It's simpler. And if we see some big downsides, then it seems that we could relax in the future. For instance, it's easy to stop frying if you are setting the transform not at the right time, for instance. And we can do as an extension point. So starting very constrained, and then maybe if we see that there's a real benefit, start to doing this migration as a follow-up. That seems appealing to me.
But the app would still need to care, right? When we say double M section, we mean the app will manually use
Yeah.
1 or 2 transceiver.
Yep. Yeah, they will use 2 transceivers. Yeah. At least initially. And yeah, we can learn from that. We can start from there. Okay. Yeah, and the last slide was related to discussion we have with Yonivar. I think that there's a way to make per packet encryption work with script transform, but there has been no request for that feature so far. So we can start simple or not support it and add it as a follow-up. Yep, Yonivar.
Yeah, so I wouldn't describe it that way. I would say more that I don't think it occurred to me to think of it as a separate use case because in my mind, choosing S-frame or S-packet is more of a technology question, what you have to interface with. And the use cases seem orthogonal. There are use cases for script transform, like adding metadata to video frames and stuff like that, that seem largely orthogonal to the technology choice there. So I'll file an issue and hopefully we can discuss and not give up on that.
So the alternative is, it's true, is to add both, so different getters, different setters, like a transform, the transform remain as is, and then S-frame transform is added as another setter. That seems more complex to me.
I mean, we can discuss the API surface separately, I think, but
okay.
But I think I'll try to file an issue to see if I understand how people are supposed to use it today, and how you're imagining it, and then the alternative, and then maybe we can discuss. It doesn't seem like we should necessarily block on API concerns. I think my understanding of the discussion was that we wanted to go with both S-frame and S-packet, and that it seemed to me doable, unless there's some reason that we can't do both. I mean, we can clearly do both. If we leave out script transform, I don't see why a script transform is inherently more complicated, but maybe we can discuss and get up to figure that out.
Okay.
That's okay.
Yeah, with a script transform, you anyway need to get the whole frame, basically. So there's no partial usage of packets and so on. So
sure, I think there are use cases for adding metadata where you could interface at the unencoded and encrypted stage, which comes after the packetization anyway.
Sure. Yeah.
Right.
Yeah, we can dig into that as well.
Great. Thanks.
So I think my plan now is to update the PR and with the feedback, restrict it more than it was and update it. And then maybe we can. So I don't know whether the plan would be to update the PR and go back to working group, or well, anyway, I think that we can. I start updating the PR. Then in editor's meeting we can discuss it, and then we can decide whether coming back to the working group is needed. But so far I understand that working on that is there's consensus on working on that, and that the direction is overall there's overall consensus on the direction with the provided restrictions. And so once the PR is along those lines, then it should be good to go, or at least good to be reviewed by editors.
That sounds good to me, with the caveat that I think there's some clarification needed on script transform and S-packet together.
Yep. Okay. Sounds good. And that's the end of S-frame.
Okay, I think I'm next. We're right on time here, so that's good. Yeah, so I'm going to be talking about media capture main, and One issue is in main and the other one is in extensions. So the first issue is clarifying what system default means. And basically here, I didn't want to create too many slides, so I'll try to cover the issue that media capture main basically uses the word system default without defining it. Does it mean OS default or user agent default? Well, the spec says, and I quote, user agents are encouraged to default to using the user's primary or system default device for kind camera microphone when possible. So if this meant, if system default meant UI default, this would make the sentence circular. So I think the right interpretation here is along the lines of, for instance, modern laptops already have built-in quote unquote primary camera and microphone. So that's probably one meaning that's intended here. And also several OSs have user configurable system defaults in their system settings UX for microphone and speakers. So a better interpretation here is that these are OS defaults. Now our spec exposes changes to these OS settings to websites through enumerate devices ordering. So basically, when you call enumerate devices, the spec says that the device that's listed first is the system default device. And you also have language that says, for instance, when new media input or output devices are made available to the user agent, or any available input and output devices become unavailable, or the system default for input and or output devices for that kind changed, then the user agent basically must fire the device change event. So the spec I think is really good here. It lets the leaves it to websites to choose whether to present what I call a flat list, or to present rely on virtual devices that some browsers have implemented. A flat list would be basically where you respond to a user's device change actions, whether they come from the OS level or the website's own UX. And then in that case, eliminating the need to present a virtual device. So while the spec likely meant to be vague here and not outright forbid UI defaults, they can hurt WebCompat in the current environment if browsers implement defaults that don't absorb the underlying complexity that having both UI defaults and OS defaults have. So if we more pragmatically, we can look at some improvements, recent improvements. The Chrome now implements a picker in its permission prompt, much like Firefox does. So at Mozilla, we really welcome this, and we expect this to improve WebCompat in this area. Unfortunately, it behaves a bit differently. Firefox actually relies on the website to interrogate which devices that get user media returned. And there's even an example in the spec for that. It's called example 6, where the website has to go call get user media, and then get user media goes, here's your stream. And then you're supposed to go into track.getSettings.device ID and basically get the device ID of the tracks that you got and store those for memory reasons. Instead of assuming that, maybe you called get user media with certain inputs and expectations. And this allows basically Firefox users to get a prompt for devices, and the defaults that the website wanted perhaps are chosen by default, but the user can override it unless the website used exact constraints. And when the request comes back to the website looks up the device IDs it's got. And that allows Firefox users to make an early decision about what camera they want to use, which works really well in most websites. There are a few websites, I would say there are more websites where that works well than not. So the difference though is when Chrome implemented this picker, Chrome instead promotes whichever device the user chooses in its prompt to be its new user agent default, maybe for that page, I'm not sure. Now this introduces WebCompat differences, because while it's true today that no browsers have a default camera setting, they do have default we do deal with default microphone settings in most OSs, and these are competing. So if we look at these two situations here, I have an example where I have an external Logitech Brio camera, which has a camera and a microphone. And so in Firefox, if I pick that device for both, it's a secondary camera and a microphone. If I pick that in the Firefox picker, I will get the input on the left. If I do the same in the Chrome picker, I get the input on the right. And you can see it's a little different. So basically, this issue is basically to clarify. I believe the spec says that the thing on the left is the correct thing. And if you look there, you'll see I've indicated the chosen device, which is listed second for cameras and third for microphones. And at the same time, you can see that the website also learns that the system default camera is FaceTime HD camera and AirPods in this case at this time. But over on the right, we see that in the Chrome side, the chosen devices are also the default devices, which is less informative, and I don't believe that follows spec. So I filed this issue basically to make sure we're all on the same page. Henrik?
Sorry, my enumerate devices knowledge is a bit rusty, but like, does an app have to care about the difference between an OS default and a browser default? And do we want them to have to care? Like which behavior is better or worse? I can't tell. Independently of what the spec says, like what do we want the spec to say and why?
Well, the intent was, and it's been finally fixed in Firefox now, is that whenever the OS system, you could try this on Mac OS, for example, if you change the system default in system settings, and if you go to the issue here, I have a larger screenshot where you can see, we can actually modify and change it dynamically what that default is. I didn't include that in this slide, unfortunately. You'll see that when you go to Mac OS system settings and change the default microphone, for example, from AirPods to Logitech Brio, you will get a device change event in Safari and Firefox. And when you enumerate devices again, you will see that the order has changed to put the new system default at the head of the list. And this works the same for microphones and cameras. Except, sorry. That would work the same for if a user agent ever supported this system default for a camera, which it doesn't in the moment. So I think the idea here was that websites could learn when users made a choice at the OS level. And unfortunately, with the new picker behavior in Chrome, it's not behaving to spec anymore, so you lose that ability. So I did a test. If you have the slide here, you'll see the link points to a fiddle where you can try yourself to do those things, and you will see that you will get updated information about user OS changes in Safari and Firefox, but not Chrome.
Okay, I'll let other people speak. I don't think I fully understand the nuances, other than that they're different, sadly.
Well, the spec basically says that when you're enumerating, put the system default device first for cameras and microphones. And I think the output on the right does not abide by that. Because you can see, it even on the right, you see microphone number 3 has the word default equals dash AirPods. So it's clearly, it has two concepts of default. There's what the user chose in the prompt, which is the Logitech Brio, at number 1 spot. And then in the third spot is the, quote unquote, OS default, which is AirPods. So it's become two competing ways for websites to learn what the OS default is, which is not great for web compat. UN?
Yes. So I agree with for microphone at least. There's an OS default, and for that thing, in that case, I think that Firefox behavior is correct according my reading of the spec. For cameras, on the other hand, there's no OS default. So we are in a bit of limbo here, and I guess you can do whatever you want. But it's a real issue because some websites, they do tend to call get user media, and then they get a track, and if the device ID is not matching the first entry in enumerate devices, they will ask again with the exact device ID. So it's not a great flow. So being explicit there would be good. So I think for microphone, we have a solution because I think the spec is clear. For camera, I don't know what we could precisely do. Because it's really a user agent default sort of.
Well, I would argue the spec even says what to do there, even though no user agent has come across this problem before. But I will mention that in Teams, for example, we have this issue in Firefox because Teams is not following the spec example number 6. But we're in contact with them and they're fixing that. So we're hoping that since Firefox has had this behavior for years, I'm fairly confident that most websites are actually following and doing the right thing here. And so that there's a model for permission prompt picking that Firefox pioneered that actually works. So I would hope we could align around that. But I would like to hear from Guido.
Okay, so just to understand, you're saying that you're thinking that the interop issue will decrease over time, even if we do nothing.
I think if Chrome aligns with the Firefox behavior, then that would only increase web compatibility, which is pretty good because of Firefox already. I mean, there are still some websites that don't work for Firefox, which I identified one, but we are actively monitoring that and addressing those websites when we come across them. And I think having a second browser work the same way would underline would help. Guido?
Well, I agree with you that that if we interpret system default as the operating system default, which is the more reasonable interpretation, Chrome has a bug here for the microphones because the microphones do have a system default, so we should list default first. So I discussed this with the permissions UI team. And basically, their intent was that the user chose. They wanted the device chosen by the user to be more default than the others. So they wanted it to feature more prominently in pickers, for example. So that's why they did it that way. But I agree that for microphones we should fix it. But for cameras, since there's no system default for camera, and it cannot be assumed that there is one. So any application assuming that the first camera is a system default, just because it's first would be wrong because there's no system default. That's why the virtual entry is useful because it lets you know if a system default actually exists or not. So I think what Chrome can do is fix the issue with the microphone, and if system defaults for cameras exist at some point, then list them first too.
Okay, I would. I'm happy that we agree on the microphone. When it comes to camera, I would argue that there is a primary device often, even if you cannot change it.
Yeah, but
There's some
so-
value in knowing what the user's primary device is, for instance, on laptops, modern laptops.
yeah, but the spec doesn't say that the first element in the enumeration is the user's primary. It says system default. So
Well, yes, but I think that is understood to be the same thing.
yeah, yeah, but then the user's primary, what's the user's primary? Because the interpretation there is a very good interpretation that the user's primary is the one that the user chose. So I mean, we can
Yeah.
change the spec to say that the
But-
first is the user's primary, but then we can argue that the one that the user chose is the user's primary because the user itself chose it.
Well, I think, we'll run
But
into
the spec doesn't say
difficulties
that,
here.
so we don't need to change that. But
Okay, but I'd like to come back to camera then, because I think it's not clear to me that I think Firefox has had this model for a while, so we have some experience with it. For instance, if you have a website that eventually wants 2 cameras, for instance, I can't, like maybe it's a game or something where you want 2 participants on the same page. You would be picking it seems clear to me that the device the user picks and whatever the system default is are conceptually different things. And so
yes,
I question the value of doing this.
I agree, but the thing with the camera is that there is no order defined on how to list cameras. I mean, we have not defined, and that order can change for different reasons. Like the operating system could change it internally, or the user agent could change it internally, or can have a UI. I mean, all that it could be allowed by the spec as long as like the only thing the spec says is system default must be first. So, but there's no system default in camera. So we need. We have some, so if that's an issue, and would be an issue because some applications might be assuming that there's all that the system default camera exists and it's the first one, but it's not.
Right.
So we need to either change the spec and introduce the concept of user's primary. And then we have to say, okay, what's the user's primary? Because like user's primary is like a vague concept. Is it something set via the user agent UI who sets it? So I think we have to open an issue to solve the case for the cameras. And yeah, Chrome can fix the issue with the microphone to list the system default first.
I think an issue would be good for camera, and knowing how Chrome is implementing the default, like because there's a user agent's primary somehow that you're implementing, and how you implement it, that can prove useful as well.
There's another issue here though, which is that the spec also says that when the system default changes, you're supposed to fire a device change event. Now, Chrome does not fire a device change event. Neither does Firefox, even though we don't change the default. So
we could change it, but maybe in this case, when the device is chosen, maybe it's not fired. But maybe it's also because in my devices there was no permission before, so you couldn't see the. So when did it change? Did it change before or after?
Oh no,
I'm not sure there's a bug there, but Chrome does fire the event if you change the system default. But I mean, this is a case when there was no permission before. So maybe
no, in every case. I mean, I don't think Chrome ever fires a device change event because I pick a secondary camera. Nor should it, would I argue. So
yeah, because it's a secondary.
My point is, my argument is that changing of system default camera was not the right tool for this, because it would require firing a device change event, which I think would be confusing.
Can you repeat that last part?
Well, the reason we have a system, I think there's a misunderstanding of what system default was meant for, which was that in the future when an operating system, maybe Linux already has an idea of a primary camera, I don't actually know. If the user makes an OS configuration change, that was supposed to try a change in enumeration order to put that device at the top and fire a device change event that the device change list changed. Now, if you go that approach, then we end up firing a lot of device change events in response to user actions, which I don't think was ever the intent.
I'm not quite sure. We would really need to understand how Chrome is defining, setting, and getting the primary device for camera to know whether firing a device change event is making sense. If you have like 2 pages that are capturing and one is actually starting to capture camera and the user is selecting through the picker, and Chrome is saying, oh, this device is the new default, then you could see a device change event flowing for the other pages, for instance, and that might make sense in that case. Because if you're calling in the other pages, get user media video auto true, what are you getting? So that's why we will need to precisely understand how Chrome is implementing the camera primary device.
Yeah, I suggest that, okay, that we acknowledge the bug for microphone in Chrome and then open an issue in camera, and then we can discuss there and give details. Okay, Chrome is doing this is doing that, and there are no defaults. So say if we want to change the spec, or if we don't want to change it, or if we want to also detect if maybe Chrome does have a bug if you say change the user primary in another page with another prompt, and then the first one doesn't see that change, but then you enumerate and you see maybe that bug exists. I haven't tried it, but
You're muted, Yaniva.
Yeah, muted.
You're muted. Yeah.
That's great. I'll file an issue. You meant I should file it on Chromium, is that right? Or the spec, you know?
well, the microphone issue that's a Chromebox, so you can
Okay.
file a Chromium bug for that, and the camera issue, if would be good to list like what's the compatibility issue that that you're observing to see if it's how big it is to see if it requires changing the spec, because I for camera I see that both browsers are according to spec. They behave differently, but they're both according to specs.
Right.
So
I think I agree with that. It's just I wish they didn't behave differently. So I'm wondering if we in Firefox, if we can resolve the issue with Teams, maybe we can come back and discuss again. So I'm curious what the benefit there is. All right. We have.
The fact that
I'm
multiple
hearing
implementers can read the same spec and come to completely different decisions about how the behavior should be is probably a sign that we should clarify something in the spec.
Yes,
unless
agreed.
unless it's like a feature that you can have different choices, but it does sound confusing.
Great. All right, I think we have so consensus on microphone, but no consensus on camera, and we'll continue discussion on camera. We have 5 minutes left. I'm wondering if we can attempt the last slide. So basically here, I filed issue 164 on MIDI capture extensions to detect speech on muted microphone. And this is a bit of a privacy gap, is that in practice, in most video conferencing systems, including this one, if you mute yourself, and I'm using the mute term loosely here, if the user hits the mute button, basically the microphone is still on, which means that the website, so that means the website hopefully isn't transmitting the audio module any bugs. So it's not a question of participants hearing you, but you have to still trust that the website is not recording you during mute. And it's not that we should all be paranoid about the, our favorite video conferencing websites, but it would be nice to not have to trust the website. And also because you will still see the red microphone indicator that tells you that the microphone is still hot. So that's for UX as well. So This also works poorly, but so the reason website video conferencing sites are doing this is quite benign. They have a nice feature that says, "Are you talking? Your mic is off. Click the mute. Click the mic to turn it on." So the idea proposal here is to, but this also works poorly with the user agent mute, for instance, pause in Safari, and also it's an obstacle for an upcoming proposal for Pepsi, where we're thinking of adding native HTML permission elements for camera and microphone. So brief napkin proposal here is basically you call get user media with a new audio constraint called detect speech activity true. And then you get the track back and you check the track settings, whether you actually got that feature or not. That's the feature detection part. And then you will get an on speech activity event fired to support the feature of "Are you talking?" basically. Thoughts?
This so this is UN. This was so there's a solution to that in Media Session API. So in Media Session, you have the voice activity Media Session, and there's an action. You can register an action handler, and it will be called when there's voice activity that is detected and the microphone is muted. This is implemented in Safari already.
Oh, okay.
And so it's a bit different. It's not at the track or get user media level, but it's somehow it's a little bit less. So yeah, you can look at the Media Session spec. It's there, it's available, and you can try it in Safari. And you are exactly right that it's a nice feature because with the Safari UX, you can mute capture, and websites can register the action handler. They can show some pop-up, and then they can call this Media Session API to actually unmute, and this should all work well.
Thank you. I wasn't aware of that. I'm definitely going to check that out.
Yeah.
Tito?
I do like the direction and the fact that the Media Session has it. I don't know if the Media Session version would need some adjustments, like in the case of multiple microphones, to know which is the one. But there's one issue here that I'm not. Just to note that I'm not completely sure that using that or having that while available or having websites more aware of this will prevent this thing, because one other reason I talked to some audio people and they told me that one reason to keep the microphone open is to keep the audio processing models working correctly with the recent audio. Let's say that say if you actually open it when you're actually going to use it, like on mute, and you stop receiving the signal, then you will get more echo than if you keep the microphone open but not transmitting. Of course, that I guess can improve, but that might be one of the obstacles for adopting the more privacy-preserving models.
When you say audio processing and echo cancellation, so the website is doing echo cancellation in JavaScript.
The browser does it, but the echo canceller that the browser does, or I mean, the application could be doing audio processing too. But even the echo canceller from the browser, I mean, it needs to warm up to adjust its parameters to do the canceling properly, and it stays warmed up if you mute it, but you're still processing the audio.
I see.
Thank you. That's good information. I think we're at time here, and so anyway, I'm dropping the proposal to check out Media Session, so that there's no conclusion needed here. Henrik, did you have a quick comment?
Well, I was wondering if web apps, since this is more detecting speech is more advanced than detecting like is volume greater than 0. Like if there's background noise, you wouldn't want this event to fire.
Right.
But if you can somehow with magical AI detect that this is in fact a voice and not me eating Doritos, then you would want to fire it. So there is a quality question as well. Like web apps would only opt in to use the UA speech detection if it's as good as the existing one. So that is something to think about. But I do agree, like I do get a tinfoil hat feeling when I click a mute button in an app and the user agent still says that I'm not muted.
For sure. And I'm very happy for, yeah. Sorry, I didn't mean to cut you off. We're a little short on time, though. But I'm very happy for Media Session to take on this complexity. So hopefully they've done a good job there. All right, thanks everyone. I think we're at time. Thanks so much.
Yeah.
Bye.
Bye for now, folks. See you soon.
Yep.